Welcome to our channel, Molten Heights Education Services. We are going to look at integration of trigonometric functions involving powers. So, our integral, in particular our trigonometric function under the study, might have a power on it. So, consider cos power y x, where the y is odd or even. So you realize that if you're integrating trigonometric functions having odd powers or even powers, you handle them differently. So for the first case, let's look at the integrals involving odd powers. Odd powers, that is 1, 3, 5, 7, and above. So consider our integral to be cos 3x. Now our y is 3, the x. I'm using cos, but it can also be a sine, basing on the problem presented. So if I have this, we know that cos 3x can also be the same as cos x in two brackets, cos power 2x. Here I'm using a knowledge of indices that if I add the powers on the first cos and the second cos, it takes me back to this. So if I'm handling integrals having odd powers, I break down the integral into other formats that are easier to deal with. So if I have that, now the integral of cos power 3x dx will be the same as the integral of cos 3 into 1 into cos squared x, but dx. So, using the knowledge of trigonometry, I know that sine squared x plus cos squared x is equivalent to 1. So, if I play with algebra, I realize that cos squared x would be the same as 1 minus sine squared x. So, if I substitute here 1 minus sine squared x, I will be having cos x into 1 minus sine squared x dx. So, this integral will give me cos x times 1, I get this. Cos x times sine squared x, I will get cos x sine squared x dx. So, if I handle this individually, I will be having cos x dx minus integral of cos x sine squared x dx. Now, you realize that the biggest challenge is how can you deal with this? This is our biggest challenge. So, now, for integral of cos x sine squared x dx, this is our challenge. How can we deal with this? So, the trick here is look at the trig function that is having a higher power compared to the other. In this case, it is sine x that is having a higher power compared to cos x. So we shall now consider a power slightly higher than sine squared x, and that will be sine cubed x. So we can let our u to equal to sine cube x. If we differentiate both sides, we get du dx is equal to 3 sine squared x, then cos x. Using your knowledge of differentiation, we get this. Now you realize that what I get is what is exactly given here. So you realize that du dx is equal to 3 sine squared x times cos x. But this is what is here. How can I make this result similar to that? So you realize that this is here. So when I cross over the dx this side and I leave du this side, I will be having du is equal to 3 sine squared x cos x dx. If I integrate both sides, I will remain with u is equal to 3, the integral of 3 sine 3 x cos x but dx. But my u is sine cubed x. So to modify it, I will be having 3 integral sine 3 x cos x dx. But my u is so 3 integral of sine squared x cos x dx is equal to my u, but my u was sine cubed x. But in my integral, I'm not having a 3, but here I'm having a 3. So I divide both sides by 3 in order to get the integral similar to this. So at the end of it all, sine squared x cos x dx is equal to a third sine cube x. Going back to my problem, the integral of cos x will give me sine x. The integral of this, I've realized it gives me negative a third sine cubed x plus the constant, if at all the parameters are not given, or the limits. So the integral of cos cubed x dx will give me sine x minus a third sine cubed x. Thank you. This is Molten Heights, and it's the rightful channel for chemistry, math, biology, physics for secondary students. Thank you very much.